Hi everybody, this is Tor Storley and I am back with another video. In this video, I wanted to take a look at a topic that I have worked with before, but I kind of rediscovered it lately and I thought I would share that with you. And that is creating path queries or hierarchical queries in Oracle. So in this video, I want to look at the Oracle methods of creating hierarchical structure queries. Okay, so as you can see, I have, a little illustration here on the side from AI. And what we're going to be looking at is this hierarchical queries in Oracle. So let's get started. There's a couple of terms we should get familiar with so you know what we're talking about. And one of them is root. Root specifies the uppermost node in the structure. So if you look down on the bottom here, you can see the root node is the first topmost node. Then, of course, each one of these is a node. And the parent node is when you have child nodes following. So both of these level 1 nodes at the bottom here, as you can see, are parent nodes. And the level 2 nodes are all child nodes. So that's kind of the layout here. There are some keywords or key operators you need to use in order to be efficient in Oracle using these hierarchical queries. And there's a term called start with, and start with will indicate where in the hierarchy you want to start. So you could be starting at the root level, you could be starting at level 1 level, or you could even be starting at level 2 level. It all depends on how you structure the query, but you need to indicate the start with keywords. And connect by means how do you connect this together? In other words, if you grab this level 2 node, you need to connect it maybe to level 1 node in order to get to the root node. So you need a connect by structure. Okay, there's also a keyword called prior, and the prior will indicate how you connect the hierarchy together. So as you can see here, you have to use it with this connect by condition. So in order for you to get from root node down to the level 2 nodes, you have to connect somehow. So that's what this prior will do. How do you connect one level to the other level? So that's what that will do. Here is an example of how to structure this query based on some of the keywords we just looked at. So here's this prior word, and you got to use that with the connect by condition. And here is an example query I generated so I can kind of explain this. So here I'm select last name, employee ID, manager ID from 8 employees table, and I'm starting with the manager ID is null. And then I connect by prior employee ID equal to manager ID. So let's look at this a little closer. Basically, the current row here, as you can see up here, is this second row, the Jones row. That's the current row. And what we're saying is, you want to start in the hierarchy here. When you run this query, you want to start with where the manager ID is null. And the only one who has a manager ID of null is me. At the first row here, you can see the manager ID is null. And that's what this is pointing to here, to null. Then, since we're in the current row of Jones, what we're saying is connect by prior employee ID. So right now, we are on the second row, and the prior employee ID will be my employee ID. Storley is 1000 because I want to set that equal to the current row's manager ID. So Jones manager ID is me, 1000. So those two will be linked together, and that's how you can set up this connect by structure. Now, here is the same thing, but I rearranged it a little bit. So as you can see, the gray query here is the same as the previous one we just did. And the one in blue is a new restructured query with just a couple of changes. It's the same query, but notice here, I'm connecting by manager ID equal to prior employee ID. So I'm not using the prior keyword before the equal sign. I'm using it after. So I'm switching the terms. I'm moving the manager ID to the left-hand side of the equal sign, and I'm taking the prior employee IDs and move it to the right-hand side. So I'm just reversing it. And when you run it like this, you will get the same result set. There's no difference. There's also something called level, which is a pseudo column that Oracle gives you. And what basically it will do, it will tell you the level that your rows are in. So if you look, for example, at me, Storley, employee ID 1000, manager ID is null. I'm the first one. The reason being, I'm starting with manager ID is equal null. So that'd be level 1. Level 2 would be the reporting structure, because we're saying connect by prior employee ID equal to manager ID. So the manager ID for the current row for Jones would be 1000. That would be me. So as you can see, Jones therefore reporting to me, and he will be level 2. Now Blake does not report to me. Blake reports to Jones because he reports to 1010, which is Jones's employee ID. And the same is true with Adams. So both of those guys will be level 3 because of the reporting structure. So that's what the level pseudo column will do. Now there's also some other functions, operators, and pseudo columns that Oracle came out with. Some of these came out, some of them have been around for a long time. Others came out with the version 10G. So there is something called sysconnect by path, which is a function. And we will look at all these in more detail in our queries. But that one will return all the ancestors for the current row. And the output will be in a row-based format. So it won't be in columnar format. It will be across rows. There's also something called connect by root, which will return the root node value. The prior, we already looked at some of this. There's one that came up with 10G called connect by isCycle. And that's a pseudo column that identifies the cycles in the data. And it's going to return a 1 if the current row has a child, otherwise it returns a 0. This no cycle is basically a check to prevent errors from happening. Meaning, let's say Jones reports to me, but then again, I mess it up and I say I report to Jones. Now we got a cyclical thing here, and that we can't do because Oracle will throw an error. But you can use this no cycle keyword that basically suppress that error from occurring. So you use this with the connect by isCycle. There's also something called connect by isLeave, and it checks whether the current node is a child node that does not have any children. It returns a 1 if this current node has a child. If it doesn't have any children, it returns a 0. So that's this connect by isLeave pseudo column. And you can use that in your query to check and see and filter by, all the nodes that doesn't have children, for example. Finally, we looked at level. We already explained what that is. So here is a final look at the hierarchical structure. So the top node is the root node. Any node that has children is a parent node, and I indicate that in yellow here. So now we're ready for some demos. So let's stop here and get into Oracle and start doing some queries. Okay, so I open up my SQL developer here for Oracle, and I open my demo database. In this database, I have a table called employees, which comes from the HR scheme, I believe. So this is what it looks like, this table. There might be a couple of columns here that are a little different, but my version of it looks like this. So if you look, there is employee ID, and then there is a manager ID as well, as you can see over here. My queries will be looking for these two columns, manager ID and employee ID. And also the last name I will be going by. So if you look at this table, the first record here is Stephen King, and he's the employee ID 100. And as you can see, he has a null in the manager ID. So that's the root record. That's the root node in this hierarchy. So let's take a look at some of the queries we can run. So here is an example how you can do a recursive query to build a hierarchy structure. So if you look at this is a CTE query. And in here, I wrote a little extra note because there is a statement in here that might confuse you a little bit. There is something called the search. So if you look down in my query here, it's a little slow because it's freezing up. If you look at my query here, you can see that search depth by first by last name set order 1. So what that one will do is it will actually look vertical to try to solve this query. The default is not depth, but it's breadth, meaning width. So in order to get it to behave normally in these CTEs, you include this search depth by first by last name set order one. As I state up here, the order one is just an internal column that Oracle would be using to do the sorts and the ordering here. So you can read up on this. I'll make this code available out on my GitHub repository. So I'll leave it like this. So what is this query doing? Well, it's a CTE. I'll call it EMP. So that's the alias for the first part here. And I'm selecting and I'm gathering some statistic inline here so I can show you the plan for this query. This is a hint that's going to gather some inline statistics on this query. And I'm querying the last employee ID and manager ID from the employees table, as you can see. And then I have a second CTE here, which is called ANSI hierarchy. Because I'm going to be recursive, I'm passing in the column structure I want to use. And here again, I have a basic select statement from employee, which I call E here. Actually comes from this one here, which I call E inside this CTE. And where I'm searching for where the manager ID is null. So that means I want to get that first record of King, that because his manager ID is null. Then I want to union it all because I'm doing this recursively. I want to first get one record and then I want to add to that record to build a table. So the second query here is from the same thing, from the emp CTE above here. And I want to join that on this query because I'm going to recursively adding. And I just give it an alias here and I'm going to connect it on the employee ID equal to the manager ID. And then I have those keywords that I showed you that I identified up here. And then I simply say from this structure here, select employee ID, manager ID, the level that we're building. Notice the level here is being gradually built up by adding one. So when it becomes 2, then you'll add 1, it becomes 3. Then you add another record, it becomes 4, and so forth. So you're building the hierarchy. This LPAD here is simply to get some indents in the output. So that's all that does. And then you can see I'm querying from this emp hierarchy, which is the second CTE. So let's run this and see what it looks like. And here you can see it comes back. Here's level 1, which is King. Manager ID is null. And here is this person is reporting to King because you can see his manager ID is 100, which King is. So as you can see now, Bates report to Cambrault, and you can see that because all of these are 148s. So that means the employee ID of Cambrault. So all of these are reporting to him. So you're building up a structure here by using this CTE. Now, one thing we can do when we run this stuff, we can look at the plan. So when I click on this auto trace button up here, you can see here is the plan it built. So as you can see here is the explain plan, and just briefly, we don't have to go through this because to verify how good your queries are and how optimized they are using this cost estimator. But as you can see, let's get a very quick look at this. You can see this CTE has a cost of $13.55. Now that doesn't necessarily mean anything by itself, but here you can see $13.55. Now that same query could be written like this. Notice how short this is, not all this traversing anything, by using a couple of these keywords. So notice I'm referring to this pseudo column level. I'm doing that same LPAD to indent the stuff, so that's the same. And here I'm using the start with. So I want to start with a manager ID of null, which would be King because he has null. And then I want to set up my connect by. As you can see, I'm connecting by prior employee ID is equal to the manager ID on the current row. So let's see what this one looks like when I run this now. And same results, I should say. And also, let's look at this auto trace for this query. Remember the old one had 1335 or something? Let's look at the auto trace on this query. Oh, wow, what an improvement. Look at this. Only 4 it cost on this one. So as you can see, this one is much more optimized than that recursive one is. Which makes sense because you're recursively building it, so you're using a lot more resources to build it. This one here is very efficient, as you can see. Now, Granted, there's very few data in here, so it probably reads the table scan, and just get it over with because it's such a small table. But regardless, I just want to make you aware of it. Okay, so that's the first introduction to the hierarchical structure and the keywords in Oracle. I'm going to show you another table that I imported from Kaggle, which is called Indian cities. And Indian cities look like this. It has an origin city and a destination city and a distance. So that's in kilometers. So for example, the distance between Agra and Delhi is 240 kilometers. At least that's how my understanding of this table is. Now, one of the things that you notice here is see Agra repeats Delhi to this city here, to this city, and so forth. There might be some problems with this data set. So let's take a look, and by doing so, we'll demonstrate some of those key concepts I laid out in my slides. All right, so let's do the first query first. And notice here, I'm starting with the origin of Agra and the destination of Delhi. And I'm connecting by the prior origin. So I'm connecting by Agra here, where I set Agra equal to the destination. Okay? So I'm going to try to connect and build a hierarchy this way. There's nothing really new here. You've seen all this L padding and everything before. So let's run this query and see what happened. And I'm getting an error here because it tells me connect by loop in user data. Okay. So remember from my slides, you could get an error because if you have a conflict, meaning an origin could be reporting to a destination and the destination could be reporting to the same origin. So you're getting cyclical kind of data here, which is not going to work. So that's why Oracle throws an error here. There's a problem here. So what we can do, we can add that NoSQL keyword and we put it right here, connect by NoSQL, and then the query is the same. So let's try that now. And notice now it actually ran, but if you look at why that was, you can see here, Agra to Delhi, but then you have Delhi to Agra. So you have a cyclical thing here, and that's not good. And when I look at this data here, it went pretty quick, but notice it only fetched 50 records. So in SQL Developer, what you have to do is you either have to do a Control A to get all the data, or you can do a count rows. So now it's going to run out there and try to bring the rest of them in. And notice there's 352,204 rows, which we know is terribly wrong because this table only has 83 records in it. So it generates a lot of the extra data here that we should see at all. Now, another thing you can do is to test for this relationship between the origin and destination and origin, whether it's cyclical or not. And you do that by adding this connect by isCycle. So let's try that now. The same query as above, I'm just adding one thing here. So let's try this one. And here it ran, and you can see here, connect by isCycle. Here it's 0 because this is fine, but here there's a cyclical thing because it detects that Delhi to Agra, Agra to Delhi, there's something cyclical going on here. So that's a problem. Okay, so that shows you how you can use that function there. And now the next thing I want to show you is if you look down at the table here, well, you can't really see it here, but I'm going to filter out the cyclical data. So I'm only going to keep those with a 0. Remember, it was like 352,000 or something. So let's try that now. Where connect by isCycle is 0. So I only want those that doesn't have the cyclical relationship. So as you can see now, I have Agra to Delhi. There's only one record here now. But notice there's still problems here because look at this one. So if I select this row and I select this row, you can see it's the same record again. There's a problem here. So I don't know what happens here, but there's definitely a problem here with duplications. So let's go to count rows and see how many rows there are here now. So remember, it was like 352,000. Now it's down to 22,000, but that's far from 83 records. So there are still problems here. And if I was trying to remove the dupes by doing a distinct on this, let's see what happens then. So I'm running this, and then I can go in and say count the rows. And now you can see we're getting 125 only. So there's a little extra here, but there's still a problem, as you can see. Look at this. It's the same thing, but now suddenly the levels have changed. So we start getting records, less and less records. And finally, by removing the level here to see if I can get this less down and run it again. And now I'm only getting 15 records back. So, but there's still, this data is no good because it's all over the place. And here I got 2 Japors to different cities. So it's still garbage, and that doesn't work for me. So what I wanted to do is I wanted to try to create a structure. So I just picked Agra to Delhi, okay? And then I followed that down, and I only picked another one with Delhi as the origin to another city. So I kind of went through that, and the way I did that was like this. Let me show you quickly how I just did this. So here is a spreadsheet I created. And what I did was I simply went in, and if I take this filter out, I simply went in and I chose a record here like this. All right. And then I set it to 1. And then I take Delhi, okay, here to this city. Okay. And then I went to this city down here and choose another city. So I went through it like that. I got some unique rows. So they should be unique now. And then what I did was I just created some select statements here dynamically, as you can see. And all I had to do was say equal, quote, select, and then point to a single quote, and then point to this cell, and double quote, single quote, and so forth. So I built the queries like this. So that's what I did in that spreadsheet. So what do I do with that? Well, what I do is I build it with a CTE out of it. So you can see here, select this and Delhi as destination, 240 as the distance from Dhul, and then I union it all. So I build my CTE like this. So let's run that query and see what it looks like. So here you can see Agra to Delhi, you have Delhi to Jaipur, and so forth. So here we have some distances in kilometers. So what I want to do now is I want to finish up those terms and the operators and function and what have you that we discussed in the slides, and I'll show you some queries that illustrates this. So the first one I want to do is just this basic one. So I'm going to comment this out, and I'm going to run this second query now. So let's see what that one looks like. So it's getting the 4 columns now. The level is the pseudo column. It's going to tell you the levels, and the rest of it you should have seen already. So let's just run that quick. So here you can see every one of these is another level, as you can see, and here you can see the indentation of every one, and here's the distance. Okay, so the first thing I want to do then is let's find the path at least here. So let's do the path. It gradually built this path. And this is the sys connect by path I talked about in my slides, where it basically go row-wise. It doesn't go vertical. It doesn't go like this city over here you can see. But the path there you can see it gradually built for every row. It gradually built the path to it. So you can see you're getting more a row-based representation from the root and on, as you can see here. Now the second thing I want to show you then is the path. So you can also do this for the path. And here what I do is I add the separator to be a plus sign. So when I run this now, you can see 240, so I just put a plus sign. Then you have 240 plus 307. So that'll be the next one. That'll be the Delhi to Jaipur. So you can build like a calculation structure here, if you will. And then what I can do, I can say there is no connect by is cycle. So I don't really need that one. And I don't really need this no cycle because I know there's no cycle. But you can see how they're being used here. They're still commented out here. But so the next thing I want to do then is I want to calculate this. So how can I do that? Well, one thing I can do, I can create a function. And the function looks something like this. Create function, calc distance, pass in something. In this case, it will be a string, the total distance path, and then return a number and give it a variable that you're going to return as a number. You can use execute immediate and then a dynamic statement like select whatever value you're passing in, which would be one of these paths. from dual into this out value and then return it. And then there's just some exception handlers here. So let's create that function and then we'll try that out. So I'm creating that function. And there's some problems with this stuff. Okay, let me try to refresh it and see if I can fix it. Okay, so there's the function, but it's invalid for whatever reason. And let me try to run it again here. Okay, it looks like it worked now. So, all right, so what I want to do then is I want to try my function out. So one way I can do that is simply in my select statement is comment this line out that calls the function and passes in a substring, which is that connect by path and the distance, the plus signs and so forth. So let's run this and see what that one looks like. And here it is. It came back. And you can see here 240 is 240, the total distance. 240 plus 307 is 547. So as you can see, that function grabs each one of these and basically builds a total distance from that one. Another thing that you might want to try to do with these hierarchies too is to maybe calculate some aggregates. Now this is not an easy task and you're going to have to experiment with this. If worst comes to worst, you will have to use PL SQL to solve this stuff. Sometimes you might want to try to aggregate some total for all the people inside the hierarchy. So here's an example of how you can aggregate a subtree, a subtree hierarchy, if you will, meaning all the children's salary aggregated, summed up to who they report to and who this person report to upwards in the hierarchy. So what I'm doing here is I'm building a subquery, as you can see, in the so-called inline view. And all it does is calculates the sum of the salary from the employees. So you bring in the employees table in twice. One, you do the hierarchy query, and the other one, you're getting some additional fields. So in order for me to run this now, you can see what it does. It calculates the sum total upwards. So in other words, here you can see the individual salaries for each person. So what happens is that the second level here, Koshar, he has children that has their own individual salary. So what happens is that you take all the children's salaries and you sum them up and then you include who they report to salary as well. All right. So here is that query and that I copied over. And if you look at it, 691,400 is what all of the people in the hierarchy's salaries total to. I just go like this. You can see down here, sum 691,400. So that's the total of all the people. And one thing it doesn't really show you here is the levels and the indentation and all that stuff. Now, if you want to do that, you might have to produce an even more complex query than I'm doing here. All right, so what I want to do is I want to find out all the child nodes in a hierarchy. So I'm going to use this connect by isLeave. So let's try it first with all of it and see what it looks like. So as you can see, it's a 1 and zeros. So the ones here are leaf nodes. Those are they don't have any children, in other words. So what I can do now is I can say, okay, get me all children in this hierarchy. And you can do that by setting into the where clause, where connect by isLeave is equal to 1. This connect by isLeave is a pseudo column. So when I run this now, I should be able to only get the children. So as you can see, here is all the children. They have a 1 in them. And here you can see the names of those. Now, so that's the connect by isLeave. Finally, then, what I want to do is I want to show you how you can order a hierarchy, because, ordering a hierarchy is not necessarily simple because it has to go with connect by and to find the parent and all that stuff. So let's see what that will look like. Now, here is the regular query, as you can see, indented. 1, 2, 3 at the levels, and here you can see them indented, the names. Now, if you look at this, notice that you have Faviet and then Chen. And then you can see it's not alphabetically sorted here. The children are not alphabetically sorted. So what I like to do is try to order this. So let's try making an attempt by using an order by last name and see what happens. And notice it's all out of whack here because now it's sorted by all the employees that it starts with A and then B's and so forth. So it doesn't respect the hierarchy at all. Now, Oracle provided a way of helping you solve this by using this siblings keyword. And the way that works is you simply do an order by last here, but you say order siblings by, and then you choose what you're going to be ordering by. So here in this case is last name. So notice now I'm going to try to order it by the sibling keyword. And as you can see below here now, the query came back and you can see king, and then you have even level 2 names you can see are sorted here. So you have C before D, before E, and so forth. And then under Pembroke, you can see you have Bates, Bloom, Fox. So now they're sorted. So that's another way you can actually make this look better by sorting the hierarchy by using the siblings by keyword. Okay, everybody, that's what I had for you today. I hope you liked my video. And if you do, give me a like, that helps. And consider subscribing to my channel. That will help me a lot too. Let me know if you have any ideas of future videos you want me to try. And give me some feedback so I can figure it out better. Because it's kind of hard to understand what you're looking for if nobody makes me a comment. So by all means, make me a nice comment, not a nasty one. So anyways, I look forward to see you very soon, and thank you so much for watching.